All right, folks, so I'm making more progress on my Hackaday IO 2023 project, which is this alternative control circuit for a mobility scooter. And I'm thinking of calling it the Easy Motion, but we'll see if I come up with a better name or not. Was originally going to go and use and adapt my previous digital potentiometer code to use this MCP 4261. But the library for this that is available on GitHub is really quite old and needs some touch-up work. It's not the worst thing ever, but I already have a working library for the MCP 4661. What's the difference between these two, aside from one is an SOIC package and one is a TSSOP? Well, this one is an SPI interface, and this one is an I2C. SPI is faster and, it has other advantages. So I was like, well, maybe I should just go with the SPI one. And good common sense and time management won this time, because I was like, I already have working code for this one. I really just need to adapt it to my new project. So I've been cleaning up that code. It looks way nicer now. I cleaned up all the libraries, fixed a whole bunch of stuff, primarily in the libraries. And I'll be able to adapt it pretty shortly here, and then hopefully start developing a prototype board that I can order out and have sent here, so I can start having something to work with. I do want to take this and actually plug it into my wheelchair first and see what happens. So I've got some calibration stuff to do. I've got some mapping of the magnetic sensor, the Hall effect sensor, to the digital potentiometer code as well. But yeah, I opted for just using I2C, aka I2C. I know it's really I2C, because like I said, I already had the code already available, and because the display I'm going to be using is SPI, the new display. I don't think I'm actually going to stick with this one. I could. I do like these a lot, but these are mostly for debugging. I ordered a really nice couple of SPI capacitive touch displays if I want to go fancy with this thing, and maybe I'll have time to do it. It'd be pretty cool. And so yeah, so that's another reason. And then lastly, I was thinking about it more and more, and I was like, how fast does this really need to be? I mean, this is such a simple device, and I know SPI can do 10 megahertz or whatever, but like, it's a potentiometer. I don't think the microcontroller in my wheelchair is really going to care if it's 400 kilohertz or if it's 10 megahertz. I think the I2C protocol in the Adafruit library defaults to 400 kilohertz, which is really fast for this kind of thing. I think it should be fine. And if it's not, cross that bridge when I come to it. I have to adapt the code anyway. So yeah, that's what's going on right now. And then my new board arrived, which I'm proud of. This is a cool little guy. It uses the unused power rail here for a no connection set of pins, and then there's pins that go directly to whatever you're trying to break out, and then it breaks it onto actual wires, so then I can use clip leads and have that over with my multimeter. A friend of mine got this multimeter for my birthday, and I really like it. And so now I can actually, let's see, I should be able to adjust if I can select the right potentiometer here. This rotary encoder is so sensitive. Part of that just has to do with mounting it properly, not on a breadboard. But you see that when I'm turning this knob here, it changes resistance. Woo! With the rotary encoder. And that's the idea. That's the whole shebang. So I could just do it with a rotary encoder, but of course I want to do it with magnetism, Hall effect sensors, and mess around with some other stuff if I need to, or even capacitive touch. Anything's better than the built-in option. But yeah, having this digital potentiometer working is really the lifeblood of the code. And so yeah, just working with the Arduino right now, and I'm quite pleased. So I'll post some more updates later.